Hello, my friends of sophisticated image texture. Today we're covering adding grain in Baselight, and I will start with explaining the add grain operator first. Then I will explain how to add external grain overlay clips in Baselight. And at the end, I will show an advanced next generation technique of adding grain that you can do with Baselight. As usual, please put your questions into the chat or comment below the videos. And also, yeah, I see some familiar names in the attendee list, so welcome to you all. Let's begin. Add grain is located in the spatial menu of the Baselight operators. Here it's the top one. And it is probably one of the more overlooked operators. On first sight, it can look quite simple, but actually it is an extremely powerful tool. The most important slider is the intensity. So we have to raise this one to start working on the image. Now, when we examine the operator in the default state, it doesn't look very aesthetically pleasing, I would say. The added grain looks very artificial, especially because it's extremely saturated here on the image. The reason for that is that add grain operates in the working color space. And modern working color spaces are white gamut spaces. That means that the red, the green, and the blue of the working color space, in our case E-gamut, they are extremely saturated, and so we're generating very oversaturated grain. Luckily, there's a cure for that. And this is for me the second most important slider of the tool, which is the channel correlation. Channel correlation means how much do the red, green, and blue channels correlate to each other. If we have 100% correlation between the three channels, that means red equals green equals blue, and that means we have black and white grain, basically. So we have a neutral color. And so in simple terms, this is a saturation slider for the grain. If we move it to the right, we desaturate the grain. If we move it to the left, we saturate the grain even further. For black and white movies, yeah, you could go all the way up to 1.0, but for colored images, I would personally not recommend that. I think a colorless grain looks a bit too artificial. So personally, I'm always using the slider in a range between 0.5 and 0.9. So my default to start with is typically 0.7 or 0.6. So let's settle with 0.7. Now our grain already looks much more pleasing than before. Another important slider is the size slider. Size 1.0 means we're generating the grain in the pixel raster of the working format. And typically this is a very fine raster, and to my taste, that grain typically looks too fine when it interacts with the actual image. I'm lowering the grain amount now a little bit so we can see that better. But I always raise that value at least a little bit, at least to 1.5, but typically I'm going more to the range of 2.0. And hopefully you can now see that this grain feels a little bit less artificially overlaid over the image that we have here. With the aspect slider, we can distort the grain, for example, for anamorphic footage. This one here squeezes it more into the X direction and this one more to the Y direction. But typically I leave that alone because in most cases we are de-squeezing our anamorphic input images via the input formats here. And then we're working with the square format in the timeline. The film response slider is also a very interesting one. Let's move to a gray ramp to examine it further. So I'm also adding an add grain operator to that shot here. So I'm adding a lot of grain. Maybe adjust the channel correlation, doesn't matter that much on this shot here. And now examine what happens here on our Luma waveform. With the film response, we can direct the grain more towards the shadows or the highlights. So the default is -1, and that means more grain in the shadows and a roll off towards the highlights. Now watch when I raise that value at 0, we have an even distribution between shadows and highlights. And if I move it more towards 1.0, now we have a much stronger effect here in the highlights, and it's fading out more towards the shadows. Currently, we are viewing that through our output DRT, going to 2.4 gamma rec 709. We can also quickly examine that in our native working space. So this is how the 1.0 film response looks like, and this is how the -1 film response looks like. Personally, I'm a fan of having more grain in the highlights, because then for me it looks clearly more distinctive, like real film grain, and not so much like video noise. But if you only have it in the highlights, then it can also look a little bit artificial. But the best approach, from my opinion, is to add grain with different sizes for the highlights and shadows. The reasoning behind this is real film grain. So there we have crystals of different sizes on the film emulsion. And when only few photons hit the film stock, then mostly the large grain crystals are activated. And the more photons hit, then more and more all the large crystals are already activated, and so they can't go any further, but then more of the smaller crystals are hit. And so that means in the highlights we have mostly smaller crystals that are activated, and in the shadows we have more larger crystals. That's how I understood the process in simple terms. And so how do we do that with the add grain operator? So first we would create one for the shadows. So let's use this one here. So there we would use a larger size. Let's go maybe with size 3 and film response -1. And then we would dial it down to a more realistic value of maybe, let's for now do 0.5. And then I'm adding another add grain, setting the film response here to 1, using a smaller size, maybe 1.8, and then adding the grain here. And so now these two grains of different sizes are now smoothly overlapping each other on the image. But it's probably hard to see that via Zoom or the video streaming platforms, but generally this gives a very nice result on the images. The white and the black roll-off can then be used further to tweak the roll-off of the added grain across the tonal range, but honestly, I rarely use these sliders. And to finish the explanation of all the parameters, at the bottom here we have the channel spread, and there we can adjust the intensity of the individual color channels. So let's examine only one add grain operator for now, the top one, and zoom in. So here you can see we can increase or decrease the intensity of the 3 color channels. Typically, I also leave those ones alone. So let's apply our grain here to the first shot that we just built and see it in playback. It's still quite intense here, so I would definitely dial it down in intensity. So let's go here from 0.5 to 0.3. And also for this one here, maybe 2.4. Yeah, that looks much better. Something like this is difficult to judge with the YouTube compression, so it's typically best if you examine this for yourself on your own machine. Okay, so how about adding grain via external grain templates? So I'm inserting one below this shot here that has a basic grade and a look layer here. So let's get my grain overlay. So these are typically footage clips that swing around 50% gray and have some grain added around 50% gray. So the first thing I need to do is I need to cut it to the length of my source shot. Here I'm cutting it, deleting the end here, going back to my clip. And the most important thing that I need to do is I need to set the input color space to my working color space. Otherwise, 50% of the source clip is not mapped anymore to 50% in the working space, and then we will introduce a density shift on the image. So here I'm working in T-log egamut, so I will use also T-log egamut as my input color space. It's now not at 50% on our waveform because we are viewing it in Rec 709, but if I would view it in T-log, we can see here that everything swings around code value 512. Okay, so now how do we add this to our clip? The only thing we need to do is insert a blend strip below. And then for the blend strip, choose the overlay or soft light blend mode. So I'm going with overlay now. And so now we have the grain as an overlay over the image. I'm zooming into the image so that we can have a better look at that. So here we can see it. If I play, we can see the added grain on the image. With the blend slider here, we can adjust the intensity of the added grain. And with the soft light blend mode, we get a slightly different result. So generally, it's a little bit less in intensity. So typically you would use a higher mix value with the soft light to get like a similar result. But this is really up to tastes. I don't have a clear preference between soft light and overlay. Okay, so let's get this back to full intensity, and I will show you what happens if you don't set the input color space to the working color space. So what if I leave this on from metadata and then it uses 2.4 gamma Rec 709 as an input? We still have the grain added now, so we can still see that there's some grain, but you can also see that now the added grain is changing the exposure and the brightness of the image, which is not what we want to do with added grain. And therefore, always set the input color space for the overlays to your working color space. But that's not the end of the options with overlaying grain. So what you should definitely try out is inserting a texture equalizer operator below your grain plate, because now you can work on the texture of the overlaid grain. So for example, we could boost up the finer structures of the grain, or we could dampen that down, and we could amplify like the 2x1 frequency octave, etc., etc. If you don't like the more coarse components of the grain, you can also dampen them down here with the texture equalizer. And so now we're getting a very different result of the grain. So maybe in playback I'm bypassing this now. Hopefully you see it's more rough without the texture equalizer, and with the texture equalizer it's a bit more smooth. We can also have a quick look at the grain plate itself. This is without texture equalizer. This is with in this example. Overlaying external grain like this has certain disadvantages. One is that the grain is not changing its size based on the exposure. So with that technique, we can't apply larger grain to the shadows and a finer grain structure to the highlights easily. And the second one is the performance of the machine. So typically it puts more stress onto the machine to process 2 input pieces of footage for each shot and then combining them. And the third one is that you need a grain plate at least as long as the longest shot in your whole timeline. So in our case, our grain clip is 10 seconds long, but that would, for a typical project, that would not be sufficient to cover the longest shot in the project. And so what I typically do when I work with grain overlays is I create a new master grain overlay for the project. So I'm doing this here now. So I'm copying this strip, and inserting it here. As far as I remember, the original length was 10 seconds. And then I'm inserting it again, and for example then flipping it, inserting again, flop, one more time, flip and flop. And then we could bring in even some more variation, for example by reversing the frame increment, playing it backwards. For a normal grain plate like this is maybe a little bit overkill, doing so much variation onto each of these segments, but I typically only used overlay grains when I also added some film dirt for certain projects, and then to have the dirt pieces not appear always in the same pattern, this really helped to randomize it up. And so then you would duplicate everything up until you have a certain length, maybe 1 or 2 minutes, and then you would render it out in the input color space, in that case our working color space, as one long piece of grain. And when you have a piece of grain with sufficient length, then it's also nice because then it easily copy pastes from one shot to the next shot. So then you can use the usual copy paste techniques, and Baselight will then always put the grain into the stack for each new shot with the adjusted settings, which is nice. But as mentioned, for my projects, I always use the add grain operator, except for 2 projects where I had to add also some film dirt. There I then used some added plates with the film dirt and grain combined that I created. Let's have a look at 2 other use cases for adding grain. And one is dealing with banding. So if we have very smooth gradients in images, for example from graphics or animation, or in this case I'm just using a bars operator and then lowering the contrast heavily on the image, and you're now probably seeing it through an 8-bit pipeline, so probably you are now seeing quite strong banding here on that gradient. Then the grain can be a nice cure against the banding downstream. So I have to make this clear. If the banding is already baked into the footage, then adding grain, or in that case we call it dither, will not help reduce the banding. It will only mask it maybe a little bit. But if the banding is happening because of going to a lower bit depth downstream, for example for the final deliverable, which will be 8-bit, then adding a small amount of grain can really help to get rid of these banding artifacts. So let's try that here. I'm adding add grain. And for these kind of dither purposes, I typically go with a low amount of intensity. In that case, we have a quite strong banding, so I go with 0.3. Usually on real projects, I might go with 0.1 or 0.2. That should be sufficient. I'm also increasing again the channel correlation. And now if I do the same moves here, hopefully you see the banding either completely gone or at least greatly reduced. So think about that, especially when you're dealing with animation content, or also if you're doing very heavy denoise and you're flattening out certain areas or blurring things, then adding a small amount of dither back to the image can really help make the signal more robust for bit depth reduction downstream. Another very simple use case of adding grain is when we're dealing with these kind of test charts. So here we have a test chart with a gray ramp and 32 photographic stops as individual steps here. And often it can be hard to read on a waveform. And so then what I usually do is I just add a little bit of grain to a test chart like this. And now we get a really nice and clear waveform image on our scopes. And the last thing I want to show you today is an advanced technique that I call texture grain. And the idea here is not to mimic most exactly original film grain, but to take the game a step further and to really model our own custom grain to our personal tastes and preferences. So what do I mean by that? So we will bring the grain to the texture domain in Baselight. So how do we build it? So let's add first a texture blend operator from the layering menu. Then now we have an incomplete stack, so below our stack we also have to add a reference, and we have to set a reference to previous layer's output. So what is now going on? Now the texture blend is combining the output of the bars strip with the output of the reference strip via texture blend, and the reference in that case is an exact copy of the bars. So at the moment it doesn't do anything meaningful. But let's imagine we have our grade here living on top of the reference strip, and so now we can blend the output of layer 5 with whatever we do here below the reference via the texture blend operator. So now I'm adding an add grain here, and let's add a decent amount of grain first. Let's set the channel correlation, maybe also the size. So here we have our grain, and so now with the texture blend I can combine via frequency octaves the image without the grain but with all the grades, and the image with the grain and the grade. So now I can say, let's zoom in again, I want to dampen down a little bit the highest frequency octave, and what often people want to do is they want to take out the roughness of the grain. Maybe you can see that here we can take out the lowest frequency octaves to only leave us with the mid and finer components of the grain. So then it appears less disturbing on some images. So let's compare the version. This is the original grain, and this is the one now processed with this texture blend preset. Here again, before, after. And in movement, it looks like this. This is with texture blend, and this is without. So let's add that to our image here. I build it again from scratch so that you can see it again how it is built. So I'm inserting a texture blend. Then above, I'm inserting a reference, setting the reference to previous layer's output. Then below the reference, I'm adding my grain. And in that case, I will also build that dual modulation grain. So let's first do one with a larger size for the shadows. Let's make that a bit less saturated. And then let's add a second grain for the highlights, which is finer. And also with channel correlation. And now we're going to the texture blend, and let's use a similar pattern for the frequency octaves, because that's what I like on many images, dampening mostly the low frequencies and also the highest frequency to some extent. So I'm zooming in. So I would say in general, still a bit too much grain here. So I'm lowering the intensity of the grain. Probably this one here in the shadows, still a bit too much. And if we zoom in quite heavily, so this is without the texture blend, this is with the texture blend, or maybe now I made it a little bit too low, so I'm raising the intensity for us to see it a little bit better. So this is without texture blend, and this is with. This is something that is best examined for yourself on your machine. Here with the compression, it's also a little bit hard to judge. And this is something that you should also always consider when you add grain. In the end, most audiences will watch the content through some kind of lossy compression. Even DCPs use the JPEG 2000 compression, which modifies the grain and the texture on images. And OTT platforms use even stronger compression typically. All right, that's what I had prepared for today. Okay, thanks for watching. Yeah, grain is always a very subjective topic, so I gave a lot of my personal preferences into that session, and other people might agree or disagree, but I just wanted to mention that for completeness. Also, I said that with the overlaid grain, you cannot modify it based on size for the shadows and the highlights. Technically, you could if you would overlay two different pieces of grain with and adding them with a luma key in the blend strip, like a hue angle. But I would say that would make it quite complicated, that whole grain topic. And that's why I usually prefer to use the add grain operator in the stack. And the last common question about grain is often where to put it in the stack, more at the beginning or more at the end. And there I have a clear preference. I always prefer to have the grain very low in the stack, so very late in the whole grading pipeline, to homogenize the images shot by shot. Because if I do it very high in the stack and very early in the process, then my grading might interfere with the grain. So on a shot that I boost up in brightness a lot, we will amplify the grain. Or if I have a shape in some area and boost up the contrast and or sharpness or brightness there, then I will also amplify the grain. And so basically I will end up with a not so homogeneous grain layer there. So that's why I'm using it usually as the last thing or very last thing. If you're adding a lot, so if you have the channel correlation more on the lower end, so if your grain is quite colorful, then it might make sense to add the grain above the look layer, so that the look layer is then also modifying the color of the grain. But if you use a high channel correlation, that from my experience, that should not be an issue. All right. So thanks for watching today. I'll see you next time. Bye-bye.